Hey everybody, how you doing? Today I have a small machining project, and it seems like some of you guys like when I do machining projects, so I thought I would do some video of it. I bought a South Bend milling vise for my lathe, my South Bend lathe at my shop. It's a heavy 10, and it's not the most useful device, but once in a while, if you need it, it'd be nice to have it. And I've been watching them online. They go for between $400 and $500 regularly. This one's been modified and it's a little beat up, so I only paid just over $100 for it. Basically what it is it goes like this. This key's into your tool post, and then this thing, you can set the angle, you can rotate it, whatever. And then it's supposed to have a vise right here on this end. And that's the part that was modified. Somebody machined it off. I don't know why. They must have thought they could take a bigger vise and bolt it on. If you notice, it's got tapped screw holes in it. And the guy I bought it from said the same thing. So I assume someone machined it off and mounted a small palm grind vise or whatever. That's why it was so cheap. But what I liked about it was if you go on eBay and look for a South Bend milling vise for a lathe, 95% of them you're going to find it for a 9-inch lathe, which look identical to this. The difference is this. This one is 1 5/8. It's upside down, but it's 1 5/8. And the 9-inch is 1 3/8. So you have to make an adapter, something to fit over this to take up the slack. So that's why I jumped on this one, because it's actually a heavy 10 milling vise. So, I mean, I could probably hunt around. Maybe the 9-inch, this part of the 9-inch is the same as the 10. I have no idea. But what I did was I bought it, and I bought a couple of cheapy little vices off eBay for I think they were 20 or 25 bucks each. I was trying to buy one with a flattish bottom that was about the same width as those slots. The idea was I would just weld a plate to them or something and just bolt it on. That's pretty much what it does. I mean, this is more versatile than the stock vise. The stock vise just has like 2 screws and a couple of jaws. It's kind of hokey. So this one I could probably machine the front flat or cut it off flat and pick up some more room on the bottom, because I'm sure that's going to hit or something. I don't know. I may never use it. My friend Scott, when I told him I bought it, he's a real machinist. He laughed and was like, "You're never going to use it. Nobody uses those things." I had one, I never used it. But hey, it was attractive and I bought it. So anyway, one of the many things wrong with this thing is that this screw, the part that makes this piece move up and down, the screw's bent. It goes in here, and it's got the brass block on the end, and it screws into it. And the screw is bent, so it needs a new screw, but this thing looks to me like it's one solid piece. I don't see any separation, so it must have been a piece of larger stock, and then they machined it down for the Acme thread. So I can't do that. I can't cut threads, first of all, but I can't cut Acme threads, let alone any threads. So I went out to buy a piece of Acme thread, and I figured I would cut this off and weld it on. And then I said, you're never going to get it straight to weld it. So what I'll probably do is I'll machine this piece of Acme thread down to this OD, and then I'll bore this thing out and slide it in, and I'll either drill holes in it and plug weld it, or I'll just use this pin. I'll just use the pinhole to lock them both together. I mean, it's a small milling vise. It's not like I'm putting all the pressure in the world on it. So the next problem I ran into was this is 7/16 10 left-hand thread, which isn't weird enough, but I guess 7/16 10 is an obsolete size. So luckily I found a place online that has 7/16 10. They don't give it away. I mean, I bought a 7/16 10 left-hand thread tap, and this piece of, it's 1 foot rod. I think it was like $40, but whatever. When you want to fix stupid things like this, you're going to pay stupid money sometimes. So let's see what we can make out of this thing. All right, our Acme rod is cut off to length. I marked it where I want to machine it down to. This recessed piece right there measures 3/12, which is 5/16. I'm going to start out drilling the hole to 1/4 inch and seeing how it looks. Zoom out a little bit. This is 1/2 inch OD. So if I bore this out to 5/16, that gives me 188 divided by 2. It's 0.94, so it's just shy of a 100 thousandths wall, which is still pretty stout. I mean, 1/4 inch would give me a hell of a lot more meat. So I'll drill it to 1/4 inch first, And I'll machine this to 5/16. If I feel confident about leaving the wall thickness just under 100, I can do that. It's probably not going to affect anything. I mean, if I really want to be super trick, I could machine some of this down to 1/4 and then pin it through there and then leave this margin right here 5/16. I don't think anything indexes into that. I believe what goes on is a collar, and then there's this graduated gizmo that goes here. So I don't think there's any reason it has to be 5/16. It's not like nothing touches that. So I think I'm safe to make it 1/4 if I want to, but let me just try to be faithful to it and go from there. Fuck, it's hot. All right, we were at like 312, right on the nose. I don't know how that happened. Okay. Okay, now we cut this piece off before we drill it. I don't know if you can see it in the camera, but this thing's really bent. I tried to straighten it out in the vise, but it's going like this. I don't know how the hell you do that, but someone did. All right, that is done. Let's get set up with a center drill and get to the rest. Let's get rid of this. Oh, it's already 1/4 inch. Look at me, huh? I mean, that's plenty of meat. So I'll run a 5/16 in a little bit and see if it looks safe. I mean, it probably is. I just don't want to make it too thin, you know. And there we go. That's plenty of meat. I'm comfortable with that. baby. We're an 1/8 inch from victory. All right. Let's see how I did. Please fit. Please fit. Please fit. Please fit. It doesn't fit. All right, means I got to machine this down a smidge. I can run the 5/16 through it again, but I think I'm gonna get anywhere. No, what am I gonna get? I'm gonna get nowhere. All right, I gotta machine this down a little more. Here's my measuring was slightly flawed. Huh. See, I measured this thing at this thing. It had like 311, 312. 312 is 5/16. That's a 5/16 drill bit. I'll measure it again, make sure I'm not crazy, but I got 312, and I got 312. I don't know what's going on. I even sanded it down. I don't know. I mean, I could probably drive it in, but I don't want to destroy it. So let me machine this back down a smidge, get it to fit, and then we'll take our victory lap. Well, this time it wasn't my meager machining skills. It was this drill bit. This is the one I was using. And it measures 302. This is an actual 5/16, and it measures 307, 307 and a half, whatever. So I don't know what this bit is. Maybe it's metric. Maybe it's just a piece of shit bit. I don't know. But I did have to machine down the shaft a smidge. But there we go. Yay, victory. Sweet, sweet victory. So now I gotta drill a hole for the pin, and we can reassemble this thing. I mean, this just screws into here, lefty, and that's how it works. It's pretty simple, really. But all right, let me get going on the rest of this and try to button it up best I can today. Okay, the hole is drilled, pin is inserted, collar is put on, it's stuck back into the housing. I threaded on the nut. Now let me slide the, whatever you call it, this gizmo piece on, and engage this piece into this hole with whatever screw it takes. All right, that Allen screw is fastened in. I put the, I think they call it a gib. It's basically a spacer shim that goes right there. You tighten these screws to take out the backlash and the play in this thing. That's all set. Now I gotta put on the graduated gizmo here and the handle. All right, there you go, it's all together. So you can set your angles here. You can set your angles down here. You know, pivot this thing this way, that way. And then this is where the vise would go. And this handle cranks this table up and down. I'm doing it one-handed, so that's how it works. So you can mount this where your tool post goes in your lathe. Then you can have jaws here. So whatever you're spinning, you can move this across. It's mainly meant for like keyway, stuff like that. Now I have to take one of those vices and try to get it to either fit in these slots or at least bolt into these holes. That's a job for another day. All right, here we are back at it again. I took the vise apart so it's easier for me to work with, and you can see that it's really close to falling into these grooves. It's off a smidge. I took some measurements this morning, and the vise is, let's make sure I'm in camera here. The vise is 1 3/8 ID up at this end and 1 3/60 on this end. I'm not surprised because it's not machined. It's just, you know, the raw casting. So the OD is 2" 440 on this end, 2" 440 on this end. So the OD is correct because that's machined. So that's not a big deal. This gizmo is 1" 453 ID and 2" 457 OD on this side. And on this side, it's 2" 457 OD. Nice job. And on this end, it's 1" 460. So this guy screwed up a little bit on this end. He's my kind of machinist. But, all right, so 1 3/8 ID. This is 1" 453 ID. and 1" 460 ID, and 2" 440 OD, and 2" 457 OD. So the OD should fall in. Doesn't seem like it wants to, but maybe once I machine the ID, it will fall in. I guess measurements don't lie. It should fall in, but I guess maybe it will. So let me work on the inside, and I should true this up. I don't know how. I mean, I guess I can make a quick pass just to clean it up, just to get the the sloppy, sandy finish off it. I'm sure you can see it in there. I've never done that before. You could probably sand it, but all right, let me get to work. And in the end, I'm probably going to take this top off too. I'd like to, am I in camera here? Yeah. I want to mock it all up and see how much this steals, because this, it's going to go like that. If this steals too much from my work area, I'll just chop it off on the bandsaw. I can't see what it's really going to hurt other than travel. I'll have to mock that up too and see. I mean, I think it's just to give this jaw strength. And again, if I'm doing like a keyway or something small, I mean, I'm not machining crazy heavy shit on this thing, so I don't expect it to be super, durable. But I mean, this side's only 3/4 inch. This side at the, at the peak is like 1.25 inches, 1.5 inches. So we'll get to that later. So for now, let me do a little machining and see what I can make happen. Okay, here we go. I have it all set up. It's actually level. I'm just gonna take a quick skim cut off both sides to give this thing a flat surface, and hopefully that does the trick for me. Let's see how we do. Yeah, it keeps moving on me. I can't get a constant cut. That's disappointing, but it's hard to hold this thing. So I'll make a cut on the other side and see how that goes. So I'm not gonna lie, I couldn't get the finish the way I wanted it. It wasn't uniform, so I just used a carbide grinder, and amazingly I got it to like 1" 380 pretty consistently down the whole inner side. So let me work on machining the base now. Okay, so now we're gonna try to make these grooves, or the center groove rather, narrower. We're gonna take about 36 thousandths off per side. So let's make one gentle pass and see how I do. Everything's locked down tight, it's square. Let's see what happens. So I'll go in, I don't know, 5 thou, 10 thou, let's do 5, let's do the gentle. 5 thou, let's see what we do. We got nothing. All right, let's go down a little bit more because it's still kind of shallow. All right, all the way out. Let's go in another 5. Make it 10 this time. Try to be gentle. I don't want anything to walk or get whacked or whatever. Take 10 the first whack. How about that? All right, I skipped ahead a little bit. This video to be 4 hours long, but there we go. Had to readjust a little bit, but it fits. It's in. It's fairly tight. I mean, do some more screwing around here and try to get to the finished product. So for today's adventure, I took everything home, and I took this base piece that's already drilled and threaded, and I just darkened up this thing with a black magic marker. And I scribed some holes. I transferred them with a transfer punch. That's these guys here. And now I have to drill through it. And these are the screws that came with it. They're going to be a little shy. I'll have to count to sink them down about 1/4 inch, but they should bite into this, and that should hold it. So let's get on to the drilling the holes portion of the show. We're all set up. I have my starter bit in here. You know, it dawned on me the other day when I was leaving my shop. I went through all that trouble to get that base piece I was machining the grooves in to get it straight and square. Why didn't I just chuck it up in the vise? I don't know why I didn't do that. I mean, I'm at my house right now, my little baby Bridgeport, but same thing. You just chuck it up in the vise. I don't know what the hell I was thinking, but... That's why it's my baby Bridgeport, because it doesn't have the power the other one has. Doesn't have that oomph. You can stall this motor out, whereas the other one you can't. This is like a 1/2 horsepower, and the other one is 1 horsepower, I believe. This is an M head. That was the early model. The other one's a J head. I mean, you can see the head is so much smaller. I'll probably edit some of this out because you don't think you guys want to watch me drill 4 holes. So let's lower the table. All right, let's follow up with a 1/4 inch drill bit. Let me shut the camera off and vac this up because it's a mess. Okay, everything is cleaned up. Now I'm going to drill the hole for the screws. You have to recess them. So the screws are a little bit short, so I have to sink them probably, I don't know, 1/4 inch, 5/16. Maybe I'll go 1/2 inch. The head measures like 380 across. 375 is 3/8. So I went the next size up. It's like 25/64. I think it's like 390. So that should give me a little bit of margin. So let me run this guy down here and test fire one and see how we do. All right, I'm going to try one, see how it goes. Oh, just pull that screw. I think it's hitting something. I'll just take it out. Fuck it. I already leveled this thing once. I'll just do it again. No big deal. Look at that. Sexy. And there we go. Hangs down about 3/8. Sunk in pretty good. So let me knock out the other 3 of these. I won't bore you with that, so stand by. And there you have it. 4 sweet countersunk holes. About the same depth. Should do the trick. And yes, I'm wearing 2 different colored gloves. And yes, I drilled an extra hole. There was already a hole there, and I countersunk it and said, why is this one so far off from this one? And then I said, oh shit, I drilled the wrong hole. I don't know what the hole's for, but all right, let me go screw this thing together and see how we did. So that's all done and mounted up. Worked out pretty well. All I got to do now is modify the heads of these screws so everything slides through here nice and easy. And I think that'll be it. Replace those 2 Phillips head screws with these sexy countersunk Allen screws I found in my drawer. I don't even know where I got them, but they work perfect. So now I will drop this back on here. And I found some Allen screws to replace the Phillips ones that I had used earlier. They fit on the countersink, so let's see if these cinch up better. See how it goes. Allen screws are cut to the right length and installed. I had to chop them off a little to clear in the bottom, but they clear. So this thing should slide perfectly. Now I'll reassemble the base to the sliding piece. Allen screw is caught to the brass piece that goes with this Acme threaded shaft. And there we go. It's all assembled. You know, it's going to sit like this. Well, this is the bottom. So that's going to sit in my lathe. And then it takes the place of the tool post. And then if you want to put something in these vice jaws, you can adjust it up or down. You know what I mean? That moves it up. That moves it down. So you can cut a keyway or whatever you want. Yeah, it's total guesswork at this point where the vise needs to be. I have to put this in my lathe, see where it sits once this is mounted, and see where this thing situates itself. Like I said, I could cut this off here to give myself another 3/4 inch of room if I need it. This may have to go up quite a bit more. You know, it's again, it was a modified milling vise that I tried to bring back to life. And I did. I mean, I got a little vise installed. Like I said, my friend Scott said I'm never going to use it. He's had them before and they're useless, but whatever. I wanted to bring it back to life so it's actually usable. So that's the story. I mean, I like to challenge myself sometimes, see what I can actually do in terms of machining and fabricating and creating. So if I never use it, that's fine. If I do use it, then I'll have the last laugh. I can say, ha, but whatever. So I hope you enjoyed seeing some of the processes I used here to bring this thing back to life. I hope I didn't waste too much of your time, but I appreciate everybody watching. And I'll be back soon with more car stuff. I got a lot of stuff cooking. So stay tuned, and hopefully I'll do something you enjoy. Thanks for watching. Hope all your projects are going better than mine. Talk to you later.